So in this video, I'm going to go through the characteristics of quadratics. So earlier in the year, we made a foldable on the characteristics of functions. And what we're going to do now is to go through the characteristics of quadratics. So we're going to go through things like domain, range, and actually maybe I'll go ahead and start listing them over here. So we're going to find the domain, we're going to find the range, we're going to find the vertex, the axis of symmetry. We're going to decide if there's a maximum or a minimum point. Oops, let me move that. We're going to look for x-intercepts, y-intercepts, increasing, decreasing, and end behavior. So we have a lot of characteristics. And again, we covered all of these in the foldable earlier in the year. All right, so I'm going to start off with drawing or graphing a parabola. So let's graph, how about, I don't know, y equals 2 x plus 1 squared, I don't know, minus 5. Why not? All right. So first thing I'm going to do is to draw my graph. So I'm just going to sketch an x and y. All right. So we can kind of work through these as we go. So first thing, in order to graph this, I need to know where the vertex is. So it looks like the vertex is at -1, -5. So I know the vertex is -1, -5. So I know the axis of symmetry is x equals -1. So -1, 3, 4, 5, -5. I'm going to say that's right there. And then I know that the axis of symmetry is right there. All right. So now I see that the a value is 2, which means that this parabola is stretched to be twice as tall as it normally is. So that means if I go over 1, instead of going up 1, I'm going to go over 1 and up 2. Instead of going over 2 and up 4, I'm going to go over 2 and up 8, which I think is that right there. All right, and then I know that the axis of symmetry works as a mirror. So I have mirror image points on the other side. So now I can do my parabola. All right. Okay, so now we're going to go through and take care of all of the other details we have. First off, domain. All right, so if I think about it, remember domain is the x values, and it's talking about the smallest x to the largest x. So how far left is this parabola going to go? Well, it's just going to keep going up and out all the way forever. So the smallest is -infinity. The largest on this side is just going to keep going out and up as well. So the largest x, it's just going to go on forever. So if you remember, this is our interval notation, so it's not an ordered pair. We always use parentheses when we talk about infinity. All right, the range. So the range is talking about the y values. We always do the lowest one first. So the lowest y is down here at -5. So this is the lowest y, and it actually hits -5. The highest y is going to be infinity, because that one's just going to go on forever. All right, now I'll give you a little hint that unless we're doing a word problem, our domain is going to be -infinity to infinity all the time. All right, maximum minimum point. Well, since this parabola is positive and going up, I know that this is a minimum. So I have a minimum point, and it's located at the vertex. All right. The x-intercept, so I'm going to pass those for just a second, come back to that. The y-intercept, well, the y-intercept is where it hits the y-axis, which looks like it hits right here at -3. So we can write it as 0, -3, or the y-intercept, we could just say is -3. Ordered pairs always look a little bit better, so I like this one the best. All right, increasing and decreasing. So basically what we're doing is when we draw this parabola, when we're going here, this side is decreasing until it gets to the axis of symmetry. And then this side of the parabola is increasing. All right, so it changes over at the axis of symmetry. And the axis of symmetry is at -1. So if the axis of symmetry is at -1, this side is increasing, which means it's increasing forever on this side. So this side is increasing. This side is decreasing, and it's been decreasing since, oops, sorry, I'm off the camera. Sorry about that. It's been decreasing forever. So the left side starts at -infinity, and it's going to be decreasing until we hit the axis of symmetry, and the axis of symmetry is at -1. So we're decreasing from -infinity until -1. All right? Then we turn. So we're not done, we're turning. We turn, and now we're increasing from the axis of symmetry until forever. So we're increasing from -1 to infinity. All right. All right, end behavior. So end behavior, we didn't do this too much when we talked about it earlier in the year, but the easiest way to do end behavior is to pay attention to where the arrows are located and what quadrants they're going to be in forever. So this arrow right here is always going to be in this quadrant. And this quadrant has positive x's and positive y's. This arrow over here, let me change colors. This arrow over here is always going to be in this quadrant, and this quadrant has negative x's and positive y's. So we're going to take that and translate that into end behavior. So this end behavior says x is just going to be more and more negative, y is going to be more and more positive. This end says that x is going to be more and more positive, and y is going to be more and more positive. Now, it makes sense that the y's are both going to positive infinity because this parabola, the arrows are going up forever. All right, so now let's go back to do the x-intercept. The x-intercept means we're solving, okay? So this right here is in vertex form. And if you remember, we started getting vertex form by completing the square. So what we can do is continue to do completing the square. The other thing that we can do, which we'll probably decide, since this is an odd number and can't divide by 2, is to go ahead and maybe change this back into standard form and then do quadratic formula. All right, so y equals 2x plus 1 squared minus 5. So I'm going to go ahead and set this equal to 0 because I really don't need this. So I need to get this in standard form. So first I need to multiply my binomials together. So x squared plus 2x plus 1. Then I need to distribute. So 2x squared plus 4x plus 2 minus 5. And then combine like terms. So 2x squared plus 4x minus 3. All right, so now I'm going to take this and do quadratic formula. All right, so negative b plus or minus square root of b squared. And then now we need to do -4 times 2 times -3. So -4 times 2 is -8 times -3 is +24. And all of that is over 2a, which is 4. So now it's just order of operations here. So -4 plus or minus the square root of 40 over 4. And I can simplify the square root of 40 because that's 4 and 10. So that'll be 2 root 10. And then, if you remember, we talked about this triangle right here. All of those can be reduced by 2. So I have -2 plus or minus the square root of 10 over 2. And those are the, oops, sorry, I'm off the camera again. And those are the x-intercepts. All right. Now, I had an idea that this was not hitting at an exact value because here at 0, I'm at -3. Over here at 1, I'm up here at +3. So I knew that this was crossing somewhere between 0 and 1. And then same with the other side. So I knew that it couldn't be factored, and I didn't want to do completing the square with the odd number, so I chose to use quadratic formula. So the x-intercepts are, so x equals -2 plus or minus square root of 10, and all of that is over 2. All right, so a lot of information. Hopefully you remember most of it because we did cover the original definitions of all of these items back in our previous unit. So now we're just applying them to the quadratics.